Welcome, students. In this video, we're going to look at multiplying rational numbers and also dividing fractions because it is very similar to multiplying fractions. Let's start out first with multiplying some decimals. We're just going to do it the traditional way that you might have learned in elementary school or middle school. And I would again suggest doing some sort of estimate before you actually go through the procedure so that you have some idea when you're done with the procedure if you missed a major step. So for instance, I could estimate, and remember this kind of estimating is not the type where you have to round to a certain decimal place, it's just rounding the number to something easy to figure out so that you can have some sort of ballpark figure for where your answer is going to be. So I might make this, you know what? Tell you what, I'm going to leave this $1.25. And I know my estimate is going to be between, I haven't done an estimate like this in a video for you before, but I know that if I have $1.25, and that's why I left it that way, because $1.25 is fairly easy to think about. You have a dollar bill and you have a quarter, multiply it by 3, and you have $3.75. Whereas if you have $1.25 times 4, then you have $4, 4 quarters, that's 5. So my answer is going to be between $3.75 and $5. I know that. So that's just another way that you could estimate to make sure you're doing this correctly. Now, the traditional way to do multiplication, some of you may have learned the lattice method, and I'd be happy to go over that with anybody who wants it. But when I taught this last year, very few of the kids actually liked doing lattice, so in the video I'm going to show you this way, but again, feel free to do lattice if you prefer that, and please do ask me if you want me to go over it with you. Okay, so when you set it up, you want to put the longer number on top. It doesn't matter which one is bigger in value, it matters which one takes up more space. Put that one on top, and then put the shorter one on the bottom. And notice that I did not line up my decimal points this time. In fact, I did a pretty bad job making it look lined up at all. But the 5s are stacked, evened up. The 2 and the 3 are even, and then the 1 is hanging out in front, excuse me, by itself. And the reason it doesn't matter if you line up the decimal points is because when you do this multiplication procedure, you're going to be multiplying this 5 by everything above, and this 3 by everything above. So whether it's lined up or not, you're still multiplying everything on the bottom times everything on top. And in fact, if you, let me show you, some people want to do this, which is not wrong at all. It's still correct. 3.5 and 3.50 are the same number, but you are giving yourself an extra step if you do it this way, because now you have a row of 0 times $1.25, which just comes out to 0, and then you have a row of zeros that you have to add together, and what is even the point of that? So I would suggest not lining up the decimal points just to save yourself a little bit of work. Okay, so we've got it set up, longer number on top, decimal points do not have to be lined up, unlike when we add or subtract. And then you're just going to take 5 times $1.25, and then you're going to take 3 times $1.25. So 5 times 5 is 25. Go ahead and put down the 5, carry the 2. 5 times 2 is 10, and then plus 2 more is 12. Put down the 2, carry the 1, and then 5 times 1 is 5, plus 1 is 6. And right now I'm not worrying about the decimal point at all. Now, when you multiply by the 3, you've actually moved one place value up. When you're multiplying this 5, keep in mind that this is in the tenths place, so this would be dimes. So thinking of 5 dimes, whereas this is dollars, $3. This is 10 times as big. So you can't just multiply by 3 and put it in this same column. You have to go ahead and put down a 0, because you're essentially, every time you multiply this 3 times something, it's really 10 times larger than if you had multiplied by this place value. So we put a 0 down to move everything over by one place value. So 3 times 5 is 15. And remember you've already carried this 2 from before. Remember to ignore that this time. You don't need it anymore. 3 times 2 is 6, plus 1 is 7. And then 3 times 1, and again, remember this 1 up here that we carried earlier, you don't need anymore. 3 times 1 is 3. And then you're going to add everything together. So this was that 50 cents times $1.50, so half of $1.50. In fact, let me write that down. This was 50 cents times $1.20. I said $1.50, didn't I? I'm sorry, $1.25. 50 cents times $1.25, which is half of $1.25. That's essentially what this row is, which should kind of tell you where the decimal point goes, but I'll show you how to do that at the end. Whereas this row was really 3 or $3 times $1.25, which is actually that $3.75 we got before. So again, that tells you where the decimal point needs to go. So since you know where the decimal points need to go now, you could go ahead and put them in, but just so you know, I'll show you how to do it after. So then you're just going to add down the columns, 7, 13, 4. And if you kind of looked what you were doing on each row, then you know this is 0.625 and you know this is 3.750 or 3.75. But the other way to do it is to look at how many decimal places you've got in your problem. There's I have so much written here. I'll try to make it neater in the next example. 2 decimal places here and one number behind the decimal point there. That gives you 1, 2, 3 total. So your decimal point goes 1, 2, 3 spaces in. So your solution is 4.375, and then just make sure that's between 375 and 5, which of course it is. So we know that our answer is at least reasonable. This will guard against you saying that the answer is 43.75, for instance, or 0.4375, something like that, where the decimal's in the wrong space. Or it'll guard in case you forgot to place the 0 down and you had gotten, gosh, that would be 10. Yeah, if you had gotten 10 down here and then put the decimal place in, something like that, then you'd know you had the wrong thing. Let's try another one. Let's look at negative 16.03 times 12 as our next example. First, we want to do our estimate. Since this is so close to negative 16, I am just going to make it negative 16. And then let me say, I could do times 12, that's not too bad, but I don't know that in my head. Well, now I could take a minute and figure it out, but let's just make it times 10. That'll still give us a good estimate. Now, when you're taking a negative times a positive, think of that as the opposite, because if you did 16 times that 10, that'd be 160. But since it's negative 16, you can think of this as a $16 debt, and you've got 10 of them, which would give you $160 of debt. So we know when we work this out, we're going to be looking for a number pretty close to negative 160. So just like before, I'm going to put the longer number on top, and I keep writing the longer number first, but it doesn't matter which one is listed first, just put the longer one on top. Okay. When you're going through the multiplication procedure, you can ignore the negative sign and then just at the end, remember to put it in. In fact, I'm going to go ahead and put it up there already so that I don't forget it. So 2 times 3 is 6, 2 times 0 is 0, 2 times 6 is 12, so put down the 2, carry the 1, and remember, ignore that. 2 times 1 is 2, plus 1 is 3. And then remember, if you're thinking about what you actually just did, all you did was 2 times 16.03, so we know the decimal point really belongs right about there, but we'll get to that. Now, when you do the next part, you're not really, remember, this is 10 times bigger in place value than the 2 was. So you're not really taking 1 times everything, you're really taking 10 times everything. So you need to put down a 0 to shift everything over 1 decimal place so that you're actually doing 10 times. So 1 times 3 is 3, but remember that was really 10 times 3, which is why we have a 30 right here. Then 1 times 0 is 0, 1 times 6 is 6, and then 1 times 1, and remember to ignore this thing you carried before, 1 times 1 is 1. Add it all together. And then again, remember, all we did was take 10 times 16.03, so the decimal point still goes right there. So even though you didn't line up your decimals at the beginning, it looks like they're going to kind of line up already, which is kind of cool. So 6 plus 0 is 6, 0 plus 3 is 3, 2 plus 0 is 2, 3 plus 6 is 9, and 1. And then there are 2 decimal places in this number, and 0 in this number. So that means the answer needs 1, 2, which is right where we thought it was gonna be. And, oh, what did I forget? Do you see what I forgot? I hope you said the negative sign. Because I looked at that and said 192 is not close to negative 160. So I knew something was wrong. And you might be thinking that's a little bit far off. And that's because we rounded the 12 to a 10. And if you think 2 times 16 is about 32, and those are about 32 off from each other. So that actually makes sense that it would be that far off, because our estimate was about 32 off. So yay, go us. Okay, let me give you a couple to try yourself, and then we'll look at fractions. All right, give those a try and then come back and check your solutions. Okay, first, I want you to check your answer, if you already got it, against the estimates. And if not, go ahead and check your estimates and see if they're at least close. So what I did here is I left that at negative 3.5, and I decided I was just gonna make that 200, because I can do negative 3.5 times 200 pretty easily. And a trick to doing that, and you can do this anytime you've got a decimal times a really nice round number like 200, first take a negative 3, I'll cover it better, there we go. First take a negative 3 times 200, which is 600. Easy enough, right? Then take 0.5, which is half, so half of 200. Well, what's half of 200? 100. So I've got 600 and 100, which makes 700, and it's negative because it's a negative times a positive. So my estimate there is going to be around negative 700. And then for the second one, I decided I was going to round this down a little bit to negative 1, and this, sorry, that's negative, so it's actually rounded up. Rounded this up a little bit to negative 1, and rounded this down a little bit to negative 220, and I got positive 220. So do note, when you have a negative times a negative, it's like a double negative. It cancels itself out. Kind of like when we had a minus a negative, it canceled itself out because it's like canceling a debt. This is the same thing. So negative times negative will give you a positive. So our answer should be around positive 220. So now I'll go ahead and do the solutions, and you can come back to check. Here's what I got. So let's look at number 3 first. I went ahead and wrote it, and this time the decimal points did happen to line up, which, great. And then this line is where I did really 0.5 times 205.1. So that kind of tells us where the decimal point will go. And this line is the 3 times 205.1. So again, that kind of tells you where the decimal point should go, because 200 times 3 is about 600. And then when I add all that together, I get 717.85. And if you had done your estimate and put up the negative sign already like I did, then you will have a pretty good chance of not missing the negative. So it is pretty close to our estimate, and we're good. Number 4. So I set up with the longer number on top, shorter one on the bottom, and this time I have 6. This is the row that was 6 times 1.265. This row was and remember it says 1, but it's really a 10. So this was the 10 times 1.265. And this row, now, make it a happy face. Since this row is really 200 times 1.265, you do have to put down 2 zeros. So every time you add a row, you add a 0, because you're multiplying one more tens place over. So this is 200 times 1.265. And notice that when you think of it this way, that always tells you where the decimal point should go. Because you know that 6 times 1 point something is going to be 7 point something. 10 times 1 point something is going to be a little bit bigger than 10. And then 200 times 1 point something is going to be a little bit bigger than 200. So then you can kind of get a preview of where your decimal point's going to end up without having to worry about counting decimal places in the problem. Okay, that was hopefully enough review for you, but if not, please let me know as soon as you can so that I can go over it with you. I know it is a lot of steps, and you probably haven't done it by hand in quite some time. But as for the video, we are going to move on to fractions. Let me turn over my paper. So when you're multiplying fractions, it's actually one of the easiest things you can do by hand, in my opinion, because, what number were we on, 5? All you do is multiply straight across and then simplify. So if I have 2/3 times 5/9 for whatever reason, I don't know. All you do is and notice you do not need to have a common denominator. No common denominator needed. Is it gonna hurt? I mean, not really. It'll hurt in that you have to do extra work that is not necessary. It's not gonna get you the wrong answer, but it's just gonna take up more of your time, so don't even bother. You're just taking 2/3 of 5/9, and to do that, you don't need your pieces to be the same size. So you just multiply straight across. 2 times 5 is 10. 3 times 9 is 27. And then just look at your answer at the end and make sure it can't be simplified, and this can't, so that's it. 10/27. What about, I keep doing these differently. How about, let's do one with an improper fraction maybe. 10/7 times 1.5. For something like this, there's 2 ways to do it. You can do the 1 and the 1/2 separately and then add the results together. So you can do 10/7 times 1 is, let me go ahead and do it both ways. This is one way. So you can do 10/7 times 1, and anything times 1 is the number itself. And then you can do 10/7 times 1/2, which is, ignore that, so you multiply across. 10 times 1 is 10. 7 times 2 is 14. And then you need a common denominator, because you're adding now. So that's 20/14 plus 10/14, which is 30/14. And then you need to simplify that. So I'm going to divide, by 2. And I get 15/7. That's one way. I don't suggest you do it that way. I think personally that there's an easier way. So the other way is to take your, let me give this enough room, is to take your 1.5 and make it an improper fraction, like we did in the adding and subtracting video, I think. Make improper. So think if you have 1 whole pie and half of another pie, that's 1 times 2 is 2, plus that additional half that you've got, that's 3 halves. So this is 10/7 times 3 halves. And then you multiply across. 10 times 3 is 30. 7 times 2 is 14. And then it's the same as up here, you have to simplify. And you get 15/7. So I kind of feel like, I think this is easier because you don't have to mess with the common denominator step, but you get the same result either way. Let's try another one. Okay, so -4/5 times 3 1/4. So you could do your estimate again, and I kind of forgot to on the others, but that's okay. This is about -1, this is about -3. Did I say negative? I meant +3. -1 times 3, so my answer should be about -3, give or take. Okay, so I'm going to go with this way of doing it. I'm going to make the mixed number to an improper fraction. I'm going to go ahead and put a negative up here so I don't forget it later. So -4/5 times 12 plus the 1 piece is 13/4. So that is, let me go ahead and put my negative sign out. 4 times 13 is, and then sometimes you're going to have to come over here and do this if it's something that you can't do in your head. So just be aware of that. But it's 52. And then 5 times 4 is 20. And I can simplify that. Those are both divisible by 2. So -26/10. And oh look, those are divisible by 2 again, which meant that this one originally was divisible by 4. But it's okay if you don't catch that all the time. And this is -13/5. Now, it may be hard to tell at first if that's close to -3. So you have to think to yourself, what would I need up here to make it 3? Or could I turn it back into a mixed number? So let's see. If I want to make this back into a mixed number, 13 is really 2 times 5, and then plus 3 more. So I have 2 wholes. So I have 5 pieces, 5 more pieces, that gets me 10 pieces, and then I have 3 pieces left over. So 2, -2, and 3 fifths. I am not on top of things today, guys. 3 fifths. That doesn't even look like a 3. Jeez. Go away. 2, and I forgot the negative sign again. -2 and 3 fifths. That is pretty close to -3. Again, that estimate is just to make sure you're in the right ballpark and you didn't make a goofy mistake like adding instead of subtracting, or forgetting the negative sign, or being over an entire place value, an entire power of 10, something like that. Okay, let me give you a couple to try. Okay, give those 2 a shot. Don't forget to do an estimate first. Okay, there's my estimates. These are actually kind of hard to estimate just because of the numbers I chose. But the way I did it was I rounded this to 1 and I rounded that to -1, so I know my answer is going to be kind of close to -1. So again, I'll be able to tell if I'm completely off on the sign or if I'm way off in place value or something like that. Same with this one, kind of hard to round, but I made this -1 and I just left this alone. So I know my answer is going to be around 2 elevenths. Here's what I got. So for this one, I turned the mixed number into an improper fraction, multiplied across, and I got -21/20ths, which is actually very close to -1. And then for this one, I just multiplied straight across. It's negative times a negative, so the answer is positive, and I got 16/99ths. Now, looking at both of these, it's kind of difficult to tell at first if those are even similar, other than they're obviously both pretty tiny. So one way to tell is to go ahead and give these the same denominator, and I'm choosing to do that because I can make 11 into 99 really easily by just multiplying by 9, and that gives me 18/99ths. And then you can tell 16/99ths and 18/99ths are very similar. And I know I got the correct sign because they're both positive. And I know I didn't make some crazy mistake to get my answer way off. So there we go. Now really quickly, I want to talk about dividing fractions, because all you're really doing is multiplying fractions with one additional step. The only thing you do differently, since division and multiplication are inverses, which means they are the opposite operations from each other. So if I take, for instance, 2/3 divided by 4/5, and I wrote times, look at me, divided by 4/5, the way I do that traditionally is to flip this to, let me write it in green, flip this to multiplication, flip this to its inverse, or its reciprocal, and then I have a multiplication problem, which I know how to do. So division becomes multiplication. I meant to do that in green so you can see what was changed. And I flip this to its reciprocal, so it becomes 5/4. And then I just multiply across. So 2 times 5 is 10, 3 times 4 is 12. Go ahead and simplify. And I get 5/6. Or if I want to do, and if I were to give you a mixed number, you would do the same thing as for multiplication, of course, because it's really the same type of problem. But let me just show you this. See, I do 9/8 divided by 5. And then think, what is the reciprocal of 5? If you need to, go ahead and make it look like a fraction. 5/1 is still 5, and it just looks like a fraction now. So I'm going to flip this to its reciprocal. So then I have 9/8 times 1/5, and then that gives me 9/40ths. And that's already in simplest form. Okay, so let me give you a few. Okay, go ahead and give those a shot. So this is how I got the first one. Flip this to multiplication, flip that to its reciprocal. So 1/5 times 2/1 is 2/5. And then here, division becomes multiplication, 4 becomes 1/4, which is its reciprocal. Multiply across and you get 3/64. Please let me know if you have any questions, and thank you for watching.